So as we did in class, I'm going to just talk again about does the distributive property mean? So what's happening is you have some kind of quantity that you want to consider at one time. And then you say, well, you have groups of. I need you to remember that when you're multiplying, what you're really telling yourself is that you have groups of. So when we say 2 times the x plus 5 as a quantity, what we're doing is we're saying that we have x plus 5, and then we have x plus 5 again. And so technically, I have 2 x's, which I show like that because that's 2 groups of x. And I have 2 groups of 5. And so a lot of times what we do is we show this rainbow method. We show this rainbow saying, hey, I have 2 groups of x and I have 2 groups of 5. And then we write it out like this, 2 groups of x and 2 groups of 5. And then we simplify saying 2x plus 2 times 5 is 10, because we can do that. And so that's what I want to see you guys doing. If we have another problem, let's say it's this. We have 2 groups of 2x, so we have 2 groups of 2x. I'm going to show it all. I have a minus, so I'm going to have a minus still here. And then I have 2 groups of 3. So I have 2 groups of 2x. That means I have 4x. Multiply the 2's together. I have a minus, and 2 times 3 is 6. So I have 4x minus 6. Now it doesn't matter where I have the number. So let's say I have 1 plus 2x as a quantity, and I have a 4 afterwards. That still is saying I have 4 groups of 1 plus 2x. So I'm still going to say I have 4 groups of 1, and now I have 4 groups of 2x. Or if you want to be really precise because the 4 is afterwards, you could write it as 1 times 4 plus 2x times 4, if that's how you want to do it. Either way, they're both going to give you 4 times 1 is 4, and 4 times 2 is 8, so you get 8x. They're both going to give you that. And in the book, it'll show 8x plus 4 because we usually write the x before the constant. And it doesn't always have to be a number. Maybe I have an x out in front. So then when I do this, I say I have x groups of x, so I have x times x. I have a minus, right? That minus follows. And I have x groups of 4, so I have x times 4. And so we have x times x, that's going to be an exponent of 2 minus, and then 4 times x is still just going to be written as 4x. Negatives are something you really want to be careful with. So if I have a negative 6 times x plus 3, then I want to be careful that I make sure that negative goes with. So I have negative 6 times x plus negative 6, I'm going to do that one, times 3. So I get negative 6x plus negative 18. And if you want to simplify that, you can say negative 6x minus 18. Or you can leave it that way. That is up to you. Be careful if there's already a minus in the bubble. So maybe I have negative 2 times 3 minus 2x. So I take that negative with the 2, and I get negative 2 times 3. I have a minus. And then I take the negative 2. I'll put a parenthesis around that to distinguish it between the minus, times 2x. So I'm just going to reinforce this. I have a negative right there. And then I have that negative right there. So I've got all my negatives covered. You should always double check that. Got negative 6 minus, and then negative 2 times positive 2x. That would be a negative 4x. And then let's look at the opposites. We're in the negative world, and then we have the opposite of that. So really I'm in the positive world. So really it's going to end up being a plus 4x. Okay, and where does this get to be kind of a little bit more difficult? One last problem here is when it's not obviously a negative number, but it is. So if I had a problem like this, if I told you to do this problem and simplify this, the negative on the 2 right here, so this negative right here is with that 2. I'm going to look at this as being a negative 2, even though it says 3 minus. This minus needs to address all of this here because it's saying minus all of this. So in order to take care of that, I'm going to take this negative with the 2. So here's how I'm going to do this. I'm going to still write the 3. I'm going to look at this being a negative 2, and I'm going to distribute. So negative 2 times 4, that's a minus 8. And a negative 2 times a positive x, so I'm in the positive world, I flip over the negative world, it's going to be a minus 2x. And by doing that, I don't have to worry about negatives later. And now I just work with the problem that I've written in blue here. And let's see, the constants, I have 3 and a negative 8, so I need to put those together. So 3 minus 8, that's negative 5, and then the minus 2x. Okay, so then the only other thing I really want to talk to you about is some vocabulary here. I'd like you to make sure these get into your notes. So let's say I have 6y plus 7y squared minus 3y plus 4. So here's some vocabulary. We have term. Okay, a term is separated by a plus, minus, and equal sign. Okay, so if I look up here, I have a plus right here, a minus right here, and a plus right here. And so everything in between my lines are terms. So 6y is a term, 7y squared is a term, 3y is a term, 4 is a term. So all these things are terms. It's a grouping of your letters and numbers, and they're grouped together because they're separated on the other sides of them by pluses and minuses and equal signs. Okay, then we have another word. It's a big word, but we're going to use it a lot, so I really need you to be comfortable with it. And this word is coefficient. Okay, coefficient is the number in front of a variable. So, numbers in front of variables, I see a y, but there's a 6 in front, so 6 is a coefficient. 7 is in front of y squared, 7 is a coefficient. 3 is in front of y, so 3 is a coefficient. The 4 does not have a variable on it, so it is not a coefficient. Okay. I'm going to go ahead and get rid of some of this stuff because I need to keep on going with the example on top. So I don't want to just scroll up and lose it. So I'm going to go ahead and erase all this. Okay. All right, and then we have the word like term. So a like term has the exact same variable. And when I say exact, I mean exact. If it doesn't have the same exponent, then it's not exact. So I'm going to write including exponents. So do you see how up here I have the 6y and I have a 7y squared? Those are not like terms because this y squared has a squared on it, whereas these y's do not have squareds. So like terms here would be 6y and 3y are like terms because they have the exact same exponent. 7y squared is not a like term with any others because there's no other 7y squareds. Then we have the word constant. That means it has no variable. And we only have one example up there. No variable, that's the 4. The 4 is a constant because that is no variable. Think about that word, constant versus variable. Constant means it stays the same, variable means it changes. But in math, variable is the x, and constant is the one without an x. So they mean the opposite of each other, just like they do in English. And lastly, I want to talk about what we mean when we say simplify. So if you're asked to simplify something, you're asked to combine like terms. So up here, there's a very little I can do. But what I can do, remember I had 6y and 3y are like terms, so I can put those together. And when we simplify, we try to write things in order. So I write my biggest exponent first. So I have 7y squared. Then I'm going to take 6y and minus 3y, and I'm going to put those together. So 6y minus 3y. So I just take 6 minus 3, and I get 3. And then I have that constant of 4, and that has no other like terms, so that's it. So this is simplify. And that is just meaning combine like terms.